Let's solve one more question. Discuss the continuity of the function defined by f of x is equal to x plus 2 if x is less than 0 and f of x is equal to minus x plus 2 if x is greater than 0. And now if you look carefully at the definition of this function, it's clear that this function is defined for all values of x except at x equal to 0. So that means the domain of this function has got two regions. In the first case, the first domain D1 is all values of x where x belongs to real numbers and x is less than 0, and the second domain is all values of x where x is greater than 0. So to check whether this function is continuous or not, we shall check the continuity of this function in both the domains. So in first case, now suppose we have a point C which belongs to the domain 1, or you can say C is less than 0. So first of all, let's find the limit of this function when C is less than 0. So the limit x approaches C, f of x is equal to limit x approaches C. Now f of x when x is less than 0 is x plus 2. So the limit is limit x approaches C x plus 2, and which is equal to C plus 2. And what's the value of the function at x equal to C where C is less than 0? So the value of the function or f of C at the point C is equal to f of C, and which is equal to C plus 2, and which is equal to the limit of the function at the point C. So that means the limit of the function as well as the value of the function at the point C where C is less than 0 are equal, or the function f is a continuous function in the domain D1. And also you can see if you draw the graph of this function for this range, then you will find that it is a straight line, and we can draw the graph of this function without lifting the pen from the plane of the paper, and which further proves that the function f, which is equal to x plus 2 for x is less than 0, is a continuous function. And now in second case, when C belongs to D2, or you can say when the point C is greater than 0, then in that case f of x is equal to minus x plus 2. So what will be the value of the function f of x at the point C when C is greater than 0? It will be minus x plus 2 or minus C plus 2. That means f of C is equal to minus C plus 2. And now let's find out the limit of this function at the point C where C is greater than 0, or limit x approaches C f of x, and that is equal to limit x approaches C minus x plus 2, and which is equal to minus C plus 2. And here again the limit of this function at the point C is equal to the value of the function at the point C. So that means the function f of x is a continuous function for all values of x which are greater than 0. So now this function is a continuous function for all values of x less than 0 and for all values of x greater than 0, or you can say this function is a continuous function in its entire domain. But you have observed something odd in this question or in the graph. You can see here we cannot draw the graph of this function without lifting the pen from the plane of the paper, because at the point 0 we have to lift the pen because here the function f of x is not defined at the point 0. But we must also remember that the point 0 is not part of its domain. So when we talk about the domain of this function is a continuous function. And now let's solve one more question. Discuss the continuity of the function f given by f of x is equal to x square if x is less than 0 and f of x is equal to x if x is greater than or equal to 0. And now if you look at this function, you can see this function is defined for all values of x. And now if you look carefully at the definition of this function, we can divide the domain of this function into three disjoint or three separate cases or three separate regions. In the first region or the first case, x is less than 0, and the second case x is equal to 0, and in third case x is greater than 0. Or in other words, you can write the first domain D1 is equal to x, where x belongs to R, such that x is less than 0, and domain D2 is equal to 0, and third case domain 3 is equal to x, where x belongs to a real number such that x is greater than 0. And our first case for the domain 1 D1, here you can see the function is defined as if x is less than 0, then f of x is equal to x square. And remember, we have already proved that the function f of x equal to x square is a continuous function. So that means for the domain D1, our function is a continuous function. And in the third case, if you look at D3, you will find that if x is greater than 0, then f of x is equal to x. And also we can easily prove that if f of x is equal to x, then it is a continuous function. And now let's move to the third case where the domain D2 is equal to 0. And now if x is equal to 0, now let's first of all find the value of the function at x equal to 0. Now if x is equal to 0, then f of x is equal to x. So the value of the function or f of 0 is equal to 0. Now let's find out the limit of the function at the point x equal to 0. And for that, let's find its left hand limit and right hand limit. Now its left hand limit or limit x approaches 0 from the left hand side, f of x is equal to limit x approaches 0 from the left hand side, and the value of f of x is x square if x is less than 0. So the limit becomes limit x approaches 0 from the left hand side, x square equal to 0 square, which is equal to 0. And the right hand limit of f at 0 is limit x approaches 0 from the right hand side, f of x, which is equal to, and the value of f of x when x approaches 0 or when x from the right hand side or when x is greater than 0 is x. So this limit becomes limit x approaches 0 from the right hand side of x, and which is equal to 0. So that means the limit of the function at x approaches 0, f of x at the point 0 is equal to 0, and which is also equal to the value of the function f at the point 0. So that means the function f is a continuous function at the point 0. So now we have proved that the function f of x defined by x if x is greater than or equal to 0, and which is equal to x square if x is less than 0, is a continuous function in its entire domain.